All right, today we're cracking open one of the biggest unsolved cases in all of science. Seriously, this is a cosmic detective story. The crime scene? The entire universe. And the victim? Well, it's kinda our whole understanding of reality. It all boils down to this one totally baffling question. Where is all the stuff?
Yeah, just let that sink in for a second. Everything we see, all the stars, the planets, the galaxies you see in those beautiful telescope pictures, all of it, everything we can touch, it's just a tiny, tiny fraction of what's really out there. The vast majority of the cosmos is, well, it's a ghost. So here's the big question. Are we missing most of the universe, or are the rules we thought we knew just plain wrong?
85%. That's the number that literally keeps physicists up at night. I mean, this isn't some small rounding error we're talking about. It's a gaping, massive hole in our inventory of the universe. Figuring out what's in that gap, that's one of the biggest quests in science right now. So let's head to the scene of the crime and see what we can find.
Okay, so to solve any mystery, you've got to start where the first clues showed up. For decades, astronomers were scratching their heads because the universe just wasn't behaving. It wasn't following the rules our physics books said it should.
You know, picture a merry-go-round spinning really, really fast. The faster it goes, the harder you have to grip to stay on, right? Well, galaxies should work the same way. We look at the stars on the far edges of galaxies, and they are whipping around at incredible speeds. I mean, they're going so fast that the gravity from all the visible stuff in the galaxy, the stars, gas, and dust we can see, shouldn't be nearly strong enough to keep them in orbit. They ought to be flying off into deep space, but they aren't. Something else, some invisible force, is holding them in place.
And the tool that first tipped astronomers off to this cosmic crime? It's something called a galaxy rotation curve. It sounds complicated, but it's pretty simple. They just plot how fast stars are moving versus how far they are from the center of their galaxy. Now, they expected speeds to drop off the further out they looked, kind of like how Neptune moves way slower than Mercury in our solar system. But that is not what they found, not even close.
And this is what makes the problem so crystal clear. That first bar, that's the speed we expect stars to be moving at, based on all the visible matter and our trusty laws of gravity. The second, much taller bar, that's what we actually see. The difference is huge. It's not a tiny little error. It's a massive contradiction. This chart right here, this is the smoking gun. This is the first piece of hard evidence that something is seriously wrong with our picture of the universe.
And it wasn't just this one clue either. There was backup evidence from something called gravitational lensing. Basically, Einstein figured out that really massive things can bend light. But when we look at huge clusters of galaxies, we see the light from behind them being bent way, way more than all the visible stuff could possibly account for. So two totally different clues pointing to the exact same conclusion. There has to be a ton of invisible mass out there, pulling things around with its gravity.
So with all this evidence on the table, the cosmic detectives had to name a suspect. And their prime suspect was a phantom, an invisible particle that fills the entire universe, a culprit we now call dark matter.
The idea behind it is actually pretty simple. Dark matter is just some new kind of particle. It doesn't give off light, it doesn't reflect light, that's why we can't see it. It pretty much ignores normal matter completely. The only thing it really does is have mass, which means it has gravity. It's the extra cosmic glue, the missing gravity we need to hold galaxies together and make all the observations make sense. And for a while there, this suspect looked like a perfect fit. It was incredible. When scientists run these giant computer simulations of how the universe grew over billions of years, if they plug dark matter into the equations, the result is a mind-blowing success. It creates this beautiful, web-like structure of galaxies and clusters that looks almost identical to the real universe we see out there. It really seemed like the case was closed. But a theory is one thing, finding the actual culprit is another.
See, the problem is, a theory isn't proof. To really close the case, you have to find the suspect. And that's what kicked off the biggest, most expensive manhunt in the history of science. Researchers all over the globe started this epic hunt for a single, tiny particle of dark matter.
And this leads to the one question that now just haunts the entire field of physics. I mean, if 85% of all the matter in the universe is this stuff, then it should be everywhere. It should be passing right through this room, right through you, this very second. So, where is it?
And the search has been absolutely monumental.
We're talking about scientists building these incredibly sensitive detectors deep, deep underground in old mines just to shield them from all the cosmic noise. We've got particle colliders like the LHC smashing protons together at nearly the speed of light, hoping to create a dark matter particle in the explosion. We've got telescopes staring into space, searching for the faintest little flash of light from two dark matter particles bumping into each other.
And the result of all that, after decades of searching? Nothing. Zilch. Not one single conclusive detection. Every single experiment has come up empty-handed. The trail has gone completely cold. Our prime suspect is still a total ghost, which has forced scientists to start thinking about a really radical alternative.
And that brings us to suspect number 2. What if there is no missing particle? What if the problem is with the laws of physics themselves? What if the rulebook we've been using this whole time to investigate the crime is just wrong?
This wild idea is called modified gravity. The theory basically says that over the enormous distances inside a galaxy, where gravity is super weak, it just doesn't work the way Newton and Einstein said it should. So if you just tweak the laws of gravity a tiny bit for those specific situations, you can explain those weird galaxy rotation curves perfectly. And the best part? You don't need any dark matter at all. Poof, gone.
So, this leaves us with two rival camps, right? Two competing ideas, and each one has some really good points and some really big problems. On one side, you've got Team Dark Matter. Their idea of a new particle does an amazing job explaining the giant web-like structure of the universe. The only problem? They can't find the particle. Then you've got Team Modified Gravity. Their idea perfectly explains how individual galaxies spin, no problem. But it has a really tough time explaining all the other evidence, like that gravitational lensing we talked about.
So, where does that leave our cosmic investigation? Well, pretty much at a stalemate, a scientific standoff. We've got two main suspects, but not nearly enough evidence to pin the crime on either one. The case is still wide open.
And you know, this deadlock has really forced scientists to get creative, to start thinking way outside the box. People are exploring some really wild ideas now. Like, what if dark matter is just a huge swarm of tiny little black holes that were born in the Big Bang? Or maybe it's a totally different, super light particle called an axion. The investigation is really branching out now, going in every direction you can imagine.
So let's just quickly recap the case file. Step 1, we found the evidence. The universe is acting weird and our theories can't explain it. Step 2, the standoff. We've got two competing explanations. Either we add a bunch of new stuff or we change the rules of the game. And step 3, the frontier. We're right at the edge of what we know, and the hunt for a real answer is on.
And all of this leaves us with a really deep, almost philosophical question that gets to the very heart of how science is supposed to work. What's the better move here? Do you invent a whole new invisible thing just to make your old theory work? Or do you find the courage to say, maybe the theory itself, the fundamental laws, are what's wrong? The answer, whatever it turns out to be, won't just solve the case of the missing mass. It's going to completely redefine our understanding of the entire cosmos.